You heard in the previous lesson the two words, current and voltage. But what is current? What is voltage? How can we measure them? These questions will be answered in this lesson. Electric current is very similar to a flowing river that flows from one spot to another. The electric current is the quantity of electricity that passes through the electric circuit. This is the dry cell that is the source of the electric current. This is the lamp that is the component that needs this electric current to glow. Let's make a closed circuit using the wires. The lamp glows. These arrows represent the movement of the electric current in the circuit. I'll now reverse the dry cell and put the positive pole to this side and the negative pole to this side. What do you see? The direction of the electric current is also reversed. What does this mean? This means that the electric current moves in one direction from the positive pole of the dry cell to the negative pole of the dry cell. The amount of current that passes through the electric circuit is 0.9 A. A is ampere. That is the SI unit of electric current, where the intensity of the electric current is symbolized by I. Then I equals 0.9 A means that the intensity of the current is equal to 0.9 ampere. So the SI unit of the current is ampere. But do you think that there's another unit of current? Yeah, it's milliampere. That is symbolized by MA. To convert from ampere to milliampere, you have to multiply by 1000, and to convert from milliampere to ampere, you have to divide by 1000. Now, how can we measure the intensity of the electric current? We measure the intensity of the electric current using an instrument called a meter, where this instrument is made up of two terminals, the positive and COM. In order to use this instrument, it must be connected in series. In series means that all the components in the electric circuit are connected end to end. Here there is an electric circuit of a dry cell, two lamps that are connected end to end, so they are connected in series. If the switch is closed, then you'll obtain a closed electric circuit and the lamps can glow. Thus, the current passes through the circuit. To measure the intensity of the current, we have to use the ammeter. Let's connect the ammeter by the electric circuit, cut the wire, and connect the ammeter in series. Take into consideration that you have to connect the positive pole of the ammeter to the positive side of the dry cell and come to the negative side of the dry cell to get a positive reading. The intensity of the current is 0.6 ampere. Now, if we connect the ammeter in the opposite way, that means connecting the COM terminal to the positive side of the dry cell and the positive terminal of the ammeter to the negative side of the dry cell, you'll get a negative reading minus 0.6 ampere. So the correct connection of the ammeter is to connect it in series, where the positive terminal is connected to the positive pole of the dry cell and come to the negative pole of the dry cell. This is the symbol of the dry cell, negative pole and positive pole. This is the symbol of the lamp. This is the symbol of the ammeter. This is the closed switch. And these are the wires, the connecting wires. We put the COM terminal here because it is the side of the negative pole of the dry cell. And we put the positive terminal here because it's the side of the positive terminal of the dry cell. The ammeter is connected properly in this circuit because it is connected in series, and the positive terminal of the ammeter is connected to the positive pole of the dry cell and come to the negative pole of the dry cell. While in the circuit, the connections of the ammeter are reversed, where the positive terminal of the ammeter is connected to the negative pole of the dry cell and come to the positive pole of the dry cell. So it's not correct. The connection of the ammeter in this circuit is not correct because it's not connected in series.